अस्सलाम वालेकुम।
वालेकुम सलाम।
वालेकुम सलाम।
मेरी स्क्रीन विजिबल है सबको?
यस
बिल्कुल।
बिल्कुल।
ओके। मेरा नाम मोहम्मद ज़ुबैर ज़फ़र है और मैं एक आई गुड गुरु पे एक मॉडरेटर हूँ। आज के वेबिनार को स्टार्ट करने से पहले हम एक ब्रीफ सा आई गुड गुरु का इंट्रोडक्शन कर लेते हैं, फिर उसके बाद हम वेबिनार की तरफ चलते हैं। आई गुड गुरु एक ऐसा प्लेटफॉर्म है जो सिलिकॉन वैली के टॉप प्रोफेशनल्स ने बनाया है, टॉप इंजीनियर्स ने बनाया है, ताकि वो पाकिस्तानी ग्रेजुएट्स और इंटरनेशनल इंडस्ट्री के दरमियान गैप को फुलफिल कर सकें। आई गुड गुरु का जो मोटो है वो है शेयर, लर्न एंड ग्रो। हमारे पास जो नॉलेज है वो हम दूसरों के साथ शेयर करते हैं, दूसरों के पास जो नॉलेज है उससे हम लर्न करते हैं और एज अ कम्युनिटी हम ग्रो करते हैं। आवर मिशन एम्प्लॉयबिलिटी क्रिएट करना। पाकिस्तान के अंदर बेशुमार ग्रेजुएट्स हैं बट दे आर नॉट एबल टू गेट गुड जॉब्स इन देयर फील्ड। सो हमारा ये मिशन है कि पाकिस्तान के अंदर एम्प्लॉयबिलिटी क्रिएट करना, ताकि जो ग्रेजुएट्स हैं वो ग्रेजुएट लेवल की जॉब्स कर सकें। हम हाईटेक स्किल्स पे फोकस करते हैं विच इंक्लूड्स लीड कोड, प्रॉब्लम सॉल्विंग, डेटा साइंस, मशीन लर्निंग। इसके अलावा हम आई गुड गुरु के ऊपर इंटरनेशनल मेंटोर्स से मुलाकात करवाते हैं वीकली वेबिनार्स में और हैकाथॉन्स में। हाउ वी वर्क। आई कोड गुरु के ऊपर 6 सेशंस होते हैं, एक दिन के अंदर एक वीकली वेबिनार होता है। जैसे अभी आप इसको अटेंड कर रहे हैं, ये वीकली वेबिनार है। इसके अलावा एक वीकली वर्कशॉप होती है जो इससे पहले हुई थी। लीड कोड का सेशन होता है। उसके अलावा फ्री आइल्स एंड जीआरई के कोर्सेज होते हैं जो इस टाइम करवाए जा रहे हैं। पाइथन प्रोग्रामिंग फॉर बिगिनर्स इसकी क्लास होती है। मशीन लर्निंग का सेशन होता है, डेटा स्ट्रक्चर्स एंड एल्गोरिदम्स। इसके अलावा अगर आप किसी भी क्लास को मिस कर जाते हैं तो आप उसको हमारे फेसबुक पेज के ऊपर लाइव देख सकते हैं। कुछ रिसेंट अचीवमेंट्स की बात कर ली जाए तो 200 प्लस इंटरनेशनल अवार्ड्स इन हैकाथॉन्स एंड कॉम्पिटिशंस। आईकोड गुरु के स्टूडेंट्स ने 200 प्लस अवार्ड्स जीते हैं इसी साल में। फुली फंडेड ग्रेजुएट एडमिशंस अराउंड द वर्ल्ड इंक्लूडिंग यूएसए। सर मोहम्मद तलहा जिन्होंने इस साल यूएसए के अंदर फुली फंडेड स्कॉलरशिप हासिल की है। उसके अलावा लोकल एंड इंटरनेशनल इंटर्नशिप्स एंड जॉब्स। आईकोड गुरु के बेशुमार स्टूडेंट्स ने इंटरनेशनल एंड लोकल जॉब्स एंड इंटर्नशिप्स हासिल किए हैं। CS50 जो हार्वर्ड का एक कंपटीशन था उन्होंने ऑर्गेनाइज करवाया था, उसके अंदर आई कोड गुरु की टीम्स वर हाईएस्ट, परफॉर्म्ड हाईएस्ट। उसके अलावा हम इस साल 2 हैकाथॉन्स ईच मंथ हमारे स्टूडेंट्स को इंट्रोड्यूस करवा रहे हैं। स्टैनफोर्ड का एक कोर्स है जिसका नाम है कोड इन प्लेस, और उसके अंदर उन्होंने स्टूडेंट्स भी सिलेक्ट किए थे और मेंटोर्स भी। एंड आई कोड गुरु वाज फॉर्चुनेट इनफ कि उसके 7 मेंटोर्स सिलेक्ट हुए हैं उसके अंदर। उसके अलावा लास्ट बट नॉट द लीस्ट, 301 स्टूडेंट्स फ्रॉम आई कोड गुरु पार्टिसिपेटेड इन गूगल कोड जैम, जबकि पिछले साल ओनली 70 स्टूडेंट्स डिड। थैंक यू। अगर आप फेसबुक से हमारी स्ट्रीम देख रहे हैं तो आप www.icode.guru के ऊपर रजिस्टर कर सकते हैं, और इसके अलावा फेसबुक पेज को आप चेकआउट कर सकते हैं। आज का जो हमारा वेबिनार का टॉपिक है दैट इज IoT, इंटरनेट ऑफ थिंग्स एंड होम ऑटोमेशन इन AI एरा। हमारे स्पीकर हैं सर फरहान महमूद। सर फरहान completed his bachelor's and master's from UAT Lahore, and he is the batchmate of Dr. Zafar Shahid. He started working in Mentor Graphics as a software development engineer, team leader and engineering ग्रुप मैनेजर। उन्होंने ये मुख्तलिफ रोल्स जो हैं वो मेंटोर ग्राफिक्स में किए हुए हैं। इसके अलावा he worked in PACE as a senior software engineer and as a principal software engineer for about 8 years. He has also worked as a principal systems engineer at RS, and he is currently working as a software consultant at Liberty Global. He possessed strong coding, development, debugging, problem solving, effective communication, and team management skills. ये सर फरहान का इंट्रोडक्शन था। बाकी सर ओवर टू यू।
Thanks, Uber, for the kind introduction. मेरा नाम फरहान महमूद है. I am a software architect and AWS certified solution architect. जैसा ज़ुबैर बता रहे थे, I have a started as an embedded systems engineer. I've grown my career from there. So I have very good skills in embedded systems. I know embedded systems inside out. Real-time operating systems, debuggers, hardware, from there, and then later on, obviously, embedded systems have many applications. For example, these days, the IoT and another application, जो कि बहुत ही specific है, that is digital TV or the entertainment set-top boxes. I specialize in that area, and working as a software architect with Liberty Global, we quite extensive experience in the consumer electronics and household devices. So to start with, I prepared a presentation and I've divided into multiple areas. I'm just going to share my screen. By the way, presentation is on. I think you can interrupt me if you have any question. I would be very happy to answer. Okay, so the आपको presentation नजर आ रही है?
जी सर, विजिबल है.
Okay, good. So to start with, brief introduction to the embedded systems, because they are the foundation or building blocks of all these things. Then I would go towards Internet of Things. We'll give a good idea of the building blocks, transport, communication protocols, discovery protocols, security mechanism, challenges, comparison factors, machine learning, artificial intelligence, IoT, or introduction to matter, which is standard evolved over the period of time. Then I would go to this set of boxes, give a functionality, advanced features, give a good overview of conventional monolithic middleware architecture versus modern middleware architecture based on the microservices, introduction to the reference to the design kit, RDK architecture, and use of personalization and artificial intelligence in set-top boxes or digital TV. So, embedded systems. Embedded system is combination है computer hardware or software which is designed for a specific purpose or a function. Embedded systems, obviously, they consist of a processor, memory, power supply, peripherals, and like quite a lot of peripherals, UART, PWM, GPIOs, SPI, I2C, timers, USB, blah blah blah, and specific applications. For example, if I go towards the digital TV, the SOC can have so many other peripherals targeted for a particular market segment. So the processor can be microprocessor or it can be microcontroller, which is already come integrated with peripherals and the memory. And microprocessor use separate ICs for memory and peripherals. So as I said, embedded systems can also use system on chip, which include multiple processors and interfaces on a single chip. And this is what the bigger systems use. For example, when we will come towards particular applications like IoT or set-top boxes, you would find that there the system on chip have all the required things. For example, processors, interfaces for a particular functional area, for example, like digital TV or anything else. So embedded systems are required to perform their function under a time constraint to keep the largest system functioning properly. And we are surrounded with embedded systems. For example, if you have a look at your home, you may have smart home appliances, coffee machine, dishwasher, fridge, washing machine. In the automotive systems, like you have engine management, advanced driving assistance systems, infotainment, entertainment, consumer electronics. This is where obviously the IoT, set-top boxes, smart TV, gaming consoles, all of these things, we are just surrounded with the embedded systems. Any questions so far? No, then I go to the next slide. So embedded system architectures, there are two popular architectures. Von Neumann architecture. This is also probably you may already be very familiar with this architecture because this is just a kind of a architecture which is used in a PC or for general purpose programming. So in this architecture, this is based on a stored program where so program basically consists of a data and instructions. So in this von Neumann architecture, both the program data and the instructions are in the same memory. And then there is it follows a fetch, decode, execute cycle where instructions are fetched from a memory, they are loaded, they are decoded, and they are executed. So this is used in general purpose computers, as I said, like the PCs and embedded systems which do not require high performance. Because obviously there we have, because we are reading the instructions and the data from the same memory, so there is a bit of a performance here. And there the Harvard architecture gives us a better performance. So here in this architecture, and I guess probably you may be very familiar with the architecture of the PC, where you have multiple registers, you have the address, for example, here you can see this MAR address register, you put the address of the data or instruction, then data or instructions appear on this MDR, memory data register. Program counter points to the next instruction, address of the next instructions in the memory. CIR is the current instruction register. So this is exactly, yeah, I guess you are already very familiar with this. In the Harvard architecture, you have separate memory systems for program instructions and data, or then you can simultaneously or concurrently, you can fetch both instructions and data at the same time. So this gives a bit of a performance edge as compared to the von Neumann architecture. So this is used very specifically where we need the performance, for example, in microcontrollers, digital signal processors, where we have a separation of program instructions and data, and we can enhance the system performance. Then this is a brief introduction to the multi-core systems. Symmetric multiprocessing, very good. Okay, I think it was a bit of a noise. Symmetric multiprocessing is an architecture जहाँ पे multiple processes होते हैं and they are connected to a single shared memory, and they often operate on the different parts of the same program simultaneously. For example, you can have quad core, you can have octa core, and all the cores are of the same type. So all these processors or the cores are considered equal and they can perform any task or the function required by the operating system. So इसमें क्या होता है, the operating system do the load balancing and distribute the workload or the task which can be run in parallel, and it just distributed across several cores, and so that they can run in parallel and give you a better performance here. Then you have the asymmetric multiprocessing. In asymmetric multiprocessing, as a computer architecture है जिसमें you have multiple processors, but each processor is assigned a separate role or a task. For example, it can be of different type. For example, one processor may be the general purpose processor. The other processor may be designed for doing a very specific task, for example, like a GPU, or it can be the digital signal processor. So इसमें क्या होता है, you run a different operating system on different cores, and yeah, and they can be with different architectures, things like that. So this gives you a benefit where, based upon the type of application, you decide what type of a processor you want in your architecture for that kind of application, and then you just run that application on that particular processor. Any questions so far? No. So a brief introduction of this real-time operating system. Real-time operating system is designed to meet the timing constraints and predictability requirements of the embedded systems, where tasks are needed to be executed within strict deadlines. So real-time operating system there is a very deterministic scheduling latency and interrupt latency. So some people might confuse that real-time operating system means the faster operating system. It is not a faster operating system, but it has very deterministic scheduling and interrupt latencies. RTOSes, lightweight भी होते हैं, they have very small footprint, which suits constraints posed by many embedded systems. So you will see that quite a lot of embedded systems, you have the real-time operating system that is the operating system for them. So typical or popular RTOSes are Nucleus, VxWorks, Unix, VROs, ThreadX. They are categorized into two categories, soft real-time systems and then the hard real-time systems. In the soft real-time systems, you have the timing constraints are not very critical, and agar aap timing miss bhi karte hain, then they do not have any fatal consequences, and they are typically quite popular. Like the examples are multimedia streaming, set-top boxes, video conferencing, gaming, blah blah blah, non-critical data processing. Then you come toward the hard real-time systems. Hard real systems where they have very strict critical timing, and missing a deadline can lead to a severe fatal. So yeah, like as you can imagine, like there, like examples are flight control systems, medical devices, automotive safety systems, nuclear power plant control systems. Now, one thing I would like to just emphasize here that embedded Linux. So this has gained very popularity in soft real-time embedded systems, because embedded Linux as an operating system just gives you quite a lot of power that comes with Linux. You get all rich set of services, functionalities, libraries, Yocto as a build system. It also have the real-time patches, although it's not strictly a real-time operating system, but still I think you can meet it to meet your soft real-time requirements. And it comes with some kind of a rich features. For example, you can have the containers, you can use them for security purposes. You can use that into your microservice architecture. Yeah. So in all of majority of the embedded systems today, majority of them, especially like in the where you can have a reasonable footprint, you will find that embedded Linux is the operating system that is powering them. So a brief introduction of the virtualization tool. Virtualization is a process where software is used to create an abstraction layer over computer hardware that allows the hardware elements of a single computer to be divided into multiple virtual computers. So you may have a hypervisor. That is a layer that enables multiple operating systems to run alongside each other. You can have multiple virtual machines, and you can have different operating systems running in those virtual machines on the same computer. So typically this concept, it came from a desktop, but it is now making its way all the down to embedded systems. You can have, for example, you can have Linux powered embedded system, and over that, one of the application is designed to run over the embedded Linux, but other application, for example, if it requires some other operating system, like you can just run that through the virtual machines. In contrast, Oh yeah, so there is another thing which is called containers. So containers provide a form of operating system with virtualization. So contain containers, you have the same operating system, uh, but you put everything that your application requires, for example, libraries, uh, all the underlying dependencies, you put that in the container, and then you are able to, it gives a very good isolation. It also gives your control over the processes. For example, you can allocate a specific memory to the container. You can grant specific permissions. So they are very popular in uh, microservice architecture. So microservice architecture, like typically came again from the cloud services. Um, but it is also making its way down to the embedded system, or specifically, it's also very popular where you want to run the same microservice which is running in the cloud on your edge computing device in the cloud native environment. So this is quite popular there. So that's why uh, I just wanted to touch that topic. Examples of the containers are LXC containers, Dockers, Kubernetes. Kubernetes are the ones which are offered, which are managed container services, which are offered by all the leading cloud platforms, for example, the AWS, uh, Microsoft Azure, and the Google. Uh, any questions so far?
सर एक क्वेश्चन है चैट में कि virtual machines are provided by AWS, Azure, and Google Cloud, right?
Virtual machines, they're not provided by Azure or Google Cloud. Virtual machines, you can have that coming from several providers. For example, the VMware, for example, Oracle, Microsoft, blah blah blah. So virtual machine is a different thing as compared to the microservice architecture powered by these containers. Um, yeah.
Thank you, sir. I was the one who asked that question.
Okay, so if you want to search in the virtual machine, you can. I'm pretty sure that you can just go to the VMware. You can go to the Google, Oracle. You can go to the Microsoft, and there are several virtual machine environments, and you can download it. You can run on your machine, which let you to run different operating system environments within them. Then you would have to download the runtime if you want to run, and then go from there.
Understood, sir. Thank you.
Okay, so now this is the thing. So these were the basics. Now with the in the modern era, so a lot of use of machine learning and artificial intelligence in embedded systems. So first thing to remember is embedded systems are like very constrained systems. They do not have that much power as the cloud can have and the cloud can scale, but they do have sufficient processor bandwidth, memory, and what is required to run, these machine learning and artificial intelligence. So, for example, you can see in a lot of embedded devices, for example, smart TVs, set-top boxes, infotainment, you have the gesture control where you wave a hand in front of, for example, smart TV having a camera, it recognizes your movements, it understand what you're trying to do, trying to raise the volume, trying to decrease the volume, things like that. All of that is done on an embedded system. Now, another thing, there is the speech recognition, natural language processing. So, although that is the function which is done, for example, this ASR, where when you speak, it is converted into the utterance, what you are speaking, that is majority done in the cloud. although now the embedded systems do have the power to be able to do the basic. For example, when you say some wake word, for example, Alexa or any other wake word, it is processed on an embedded system to understand what what the utterance user is saying, and then what it does, it do the basic recognition, further, but majority is still done in the cloud, because embedded systems have a very limited memory processing power, but some they do allow some kind of a speech recognition capabilities at the moment. Uh, Computer vision is another area where embedded systems leverage the machine learning algorithms for computer vision tasks, object detection, recognition, tracking. The very good example there is in automobiles, uh, advanced driving assistance systems, for example, to start with adaptive cruise control, where the car is maintaining a distance from the other car through the radars and all that. Their car, yeah, this is a kind of that, to the full self-driving cars. This is all computer vision. Then you can have some automated assembly plants where some kind of a PCB are manufactured, and where through the computer vision, some robot is identifying that, like this part is not good, this is good, all of that. So this is all computer vision, where the computer have that intelligence through the machine learning algorithms, and it is looking at information coming from different sensors, cameras, and doing all this kind of intelligence. Natural language processing, as I said, like this is another where obviously to process and understand the natural language, obviously one form of that is your ASR, which is further processed, and there the intelligence comes, which is converted into the intent. For example, on my set-top box, if I say Netflix, it knows that, okay, user is trying to say that open the Netflix. Or it says BBC, it knows that user is saying tune to the BBC. So it tries to guess what the user intent is. Yeah, it can do the translation, sentiment analysis, autonomous systems I already covered. Adopted systems, all, yeah, for example, you can have all these machine learning, artificial intelligence techniques enable embedded system to adopt and learn the new environment. For example, you can have the smart thermostat, they can learn your habits and the environment. They know like how quickly the room can be heated or it can be cooled, and the timing you turn that on, things like that. They adopt themselves, and they're self-learning, so they're quite adaptive. So quite a lot of applications of all these machine learning and artificial intelligence in embedded systems. Any questions? Okay, now one application, as I said, Internet of Things. This is quite an interesting one because, yeah, Internet of Things is referred to a network of physical devices. You can have physical devices, you can have a network of vehicles, you can have a network of appliances, or any other objects which are connected to the internet. So Internet of Things. So the idea revolves around connecting or integrating these things to enhance functionality, automation, and data-driven decision making. So I just try to summarize here the building blocks or the layered overview. So at the very bottom, you have a physical device. Now, physical device is an embedded system. It can be a sensor, blah, blah, blah. Then all of these are the protocols or the transport that are available in them. And quite a popular one, I would say, is, and my favorite, I think, Bluetooth Low Energy. You have a Wi-Fi, You can have the Zigbee RF4CE. You can also have the full-fledged Bluetooth. You can have Z-Wave, a lot of different protocols, different transports that are available to suit all different needs of these applications. Then you have these gateways which offers uh, connectivity, and you can have them over 3G, 4G, 5G. You can have them over the Ethernet, over the power line. You can have all sort of connectivity there. And then obviously you have the connectivity management platform, for example, APIs, billing systems, management, device management, application management, um, to manage the device, to provision the certificates, to capture the data for analytics. And then you have over top, at the top, you have a very specific application which is designed for very specific use case. For example, the home security, industrial automation, health, all of that. So this is just a very high level, a very generic overview how uh, IoT stack in general looks like. Any question? So as I said, the different or popular transports used in IoT are Zigbee RF4CE. So this is kind of a RF radio frequency protocol at 2.4 gigahertz. This is quite popular, I would say. Well, I have seen quite a lot of applications in remote controls, smart meters, electricity meters. What else? To be honest, you can have also your in-home security, for example, small devices to monitor if the window is like intrusion detection, all those kind of things. Then you have this BLE, Bluetooth Low Energy. This is also 2.4 gigahertz. This is well, you may it's not very similar to the Bluetooth. They are quite different, but it does give an advantage that it is designed for embedded platforms. Specifically, gives you very low power consumption. So again, I have seen that used in remote controls, security systems, intrusion detection alarms. Yeah, quite a lot of applications. Then we have the Bluetooth. This is where the full-fledged Bluetooth comes in, and you can have a full-fledged audio streaming over the Bluetooth A to D, DP profile. You can have, I think this is also quite useful in setting up the IoT device. You just connect via Bluetooth from your handheld device, like the mobile phone, and configure quite a lot of parameters of which that IoT device requires. So this is used there as well. Wi-Fi, this is ever green thingy. you, yeah, this gives an advantage that you can have the full IP stack running on an embedded IoT device, and you can do anything. Thread is a low power, low latency wireless mesh protocol, networking protocol. Z-Wave is another RF protocol. Then you have an overview of different IP communication protocols used in IoT, which can be HTTP, HTTPS. These are what are used to set up the REST services or the REST APIs. You can also have the WebSocket or the secure WebSocket. If you want to have some kind of a real-time communication with the events, this is where you use your WebSocket or secure WebSocket, and then you have the MQTT, which is messaging protocol let you to exchange the information in a scalable way where you have listeners, and then when you publish a message, a listener subscribe to a message, and when the message is published, all the listeners get receive the message. So it's quite scalable there. Uh, any questions? So different discovery protocols in IoT. So you have a lot of devices in maybe in your home automation. The question is how these devices are discovered. There are different protocols for local or land-based discovery and the wide area network-based discovery. In the local discovery, there is a one quite popular protocol. It's called Simple Secure Discovery Protocol, SSDP, and another protocol is Multicast DNS. That let the devices to be discovered over local area network through these protocols exchange. Um, Obviously, it's not going to work over the wide area network. Over the wide area network, you discover through the cloud where the service provider has set up some kind of a service, and IoT device connect to a service, and it pair with that service and store its pairing data there. So that's a wide area network discovery. Then you have your different security mechanisms using IoT devices. You can have the transport layer security, you can have the SSL, you can have the client authentication using client certificates. Now, TLS is a very, this is what is used, or SSL, which is what is used over HTTPS or over secure WebSocket, which where there is a handshake between the client and the server to the client hello, and then there is a server hello, and then there are some secrets exchange cipher protocol, and then this is how devices are able to make sure that they can exchange the information without any eavesdropping or some man in the middle impact. Because obviously, if there is some man in the middle, it would not have the secret, and obviously, it would not be able to decrypt the messages there. And this is how it protects against us. And another thing which I would like to expand into is this client authentication using the client certificate. This is quite important to understand. Um, in IoT, I think one of the fundamental challenges is how I can uniquely identify what the IoT device identity is. There can be, like quite a lot of bot activity भी हो सकती है, which would be, like which can cause denial of service, and it's very hard to identify. So what it can also, be very difficult for the service provider to identify which devices can legitimately use my services, and I don't want to, serve other devices or give the information to the other devices. So वहाँ पे हम क्या करते हैं? Then you use the client certificate, you provision a certificate into the device. The certificate is obviously is provided by the generated by the known CA providers, and the certificate obviously have the two parts: private key and the public key. So it's called PKI, public key infrastructure. So the private part of that, then that is kept with the device. Only device know what is the private, and that is called a secret. And the public key is shared with the other entities like servers, gateways, so that they can establish a secure communication. So hota ye hai कि when the device want to authenticate into a server or a gateway, it uses its private key to sign a message or a digital signature. और server क्या करता है? Can verify the authenticity of the device by using the corresponding public key. Having a public key, it is able to decrypt that message. As I said, I was explaining this TLS and SSL. This can be established using the encryption algorithms, cipher algorithms, and extending the through the handshake by exchanging, like some kind of a secrets. So इसमें होता ही है कि आप then device uses the public key of a server or a gateway to encrypt the data up, because you can public key is available to everyone, and then when the information reaches to the server. Server के पास private key होती है, and then server is able to decrypt that. So this is how, like all of this is done. It also provided the data integrity. Um, as I said, the certificate authorities, yeah, like they issue and manage the digital certificate. For example, you can have it issued by Amazon, Norton, Google. There's a lot of certificate authorities, GoDaddy, blah blah blah. So, any questions so far? Okay, so key challenges in IoT. सबसे इसके अंदर important challenges होते हैं interoperability and standards. जैसा मैंने overview दिया था, you have a lot of variety of transports available, and previously, when these IoT devices came into the existence, I think they are there. I think probably if I go back, I think maybe 8-10 years ago, everybody just keep creating a one or its own standard. वहाँ पे there were no kind of a standards which defines how the interaction between the devices looks like, what data structures or messages are going to look like, things like that. So as a result, there was very little interoperability that used to exist between the devices unless the devices are coming from the same manufacturer, uh, or there were used some cloud services, for example, IFTT, which was offering the integration with the multiple devices, and through their cloud platform, the interoperability was achieved. Security is also a very challenging area there, because obviously a lot of these devices are, for example, in the home automation, they are in your home. You do not want, and they need to be, like all, if they need to be robust with all their encryption mechanism, access control, data protection. Otherwise, your house is going to be very vulnerable. So, yeah. Another key area is the privacy, because these devices are capturing a lot of your data, which can be your private data. And obviously, they have a very good knowledge of all that activity, and if can be that can be used to target, make you vulnerable. They can use that information to target you with. They can upselling things. They can target, if that data is leaked, it can be used by criminals, things like that. The privacy is always a big concern, and there are a lot of regulations that or legislations that can do the consumer rescue there. For example, GDPR in Europe, to make sure that if in case of any breach of their private data, the manufacturer or the service provider is liable there. That, yeah. Scalability is also a very big challenge, because all of these, well, quite a lot, yeah, as these are embedded systems with a limited memory, limited computing power, how they scale to the, like, yeah, for example, if you're running a microservice on a, like for the edge computing device in a cloud native environment, how it is going to scale. Yeah. Power management, obviously, because of the nature of these or the use cases that are in the IoT, for example, remote control that is battery powered, or like some security camera that is battery powered, or some kind of a intrusion detector mounted on your door, which is, so these are very limited power, and that's where the challenges come to have the optimal transport and the power consumption or the power management to make sure that we make all of these use cases get the benefit out of them. Otherwise, yeah, it's a good challenge to solve in the IoT. Reliability and default tolerance, so redundancy and resilience is also because obviously these are the embedded devices. Any questions? DLA Akbar, go ahead.
Assalamu alaikum, sir. I have asked you questions in the chat. If you can look and see them.
Oh, okay, just give me a second. Oh yeah, here is the chat. Remote agriculture management system. Okay, good. Soil health through our mobile app. What infrastructure I need to look for, like specific hardware? I would say if you want to do the prototyping, you can use the Raspberry Pi. It would be a good one, or you can use the Arduino. I personally would go with the Raspberry Pi, and obviously, as I said, you need to interface with some kind of sensors. And I think you need to look for what sensors are you going to read the soil health, water. I think you can use the hygrometer, but obviously you have to find the sensors, and then you can interface with your, for example, the Raspberry Pi or the GPIOs, which are the general purpose IOs, which can be configured as input or output. Obviously, then you can take the readings from the GPIOs, and then you can write your application. You can write that, like in prototyping, you can write that in the Python or whatever language you're comfortable with, it's up to you. And then remote setting, obviously, I would say obviously just Raspberry Pi comes with the Wi-Fi. So what you can do is to set up a service. You can set up a REST API server there, HTTP web server. You design some APIs, you put the REST service there and make it a REST server. Obviously, to make it remotely available, typically the IP which is assigned to you by the broadband provider, it can change over the period of time. So you need to come up with something which you can get a fixed IP, or you can use services like the Dyn DNS, so that whenever your IP is updated, then the Dyn DNS knows and it resolves, it points to the IP of the device that you'll have. So that way, anyone, like then you call that service from outside, you call, call the API um, uh, through the postman, or, just put that in the URL or using the curl from the command line. It would hit that endpoint and it would be able to get that information, what you're providing according to the communication protocol you designed. So I would say Raspberry Pi with the Wi-Fi shall be good enough. Plus, obviously, the sensors hooked over the GPIO, I think that shall be good enough for this kind of prototyping.
Thank you, sir.
अगर आपने वैसे check करना है कि Raspberry Pi, I don't like where it is available for Pakistan, but in UK it's quite cheap. It is, I think it's around 30 or 35 pounds, something like that. I'm pretty sure. I think maybe. Oh yeah. So if you maybe you can go to like AliExpress, you can get that shipped from China. It would be quite. I would say quite reasonably available. Okay. Okay, great. Let me go to the next one. Now, IoT comparison factors evaluation metrics. Now, as I said, obviously, depending upon the use case, you can find several comparison factors or evaluation metrics which you can judge your IoT device on. You can have some scalability considerations, reliability considerations, security, power consumption, battery powered or mains powered. To be honest, I think most of these use cases require battery powered. Resource efficiency, then latency requirements, bandwidth, data throughput requirements. For example, like video conf, good they require a good bandwidth. You can have like some data to be occasionally exchanged. Those are the low bandwidth requirement. Then you find your suitable transport and the devices that are fulfilling all of these requirements. So these are the factors which you think when you want to target a particular device, transport, and other considerations for thinking about your use case. For example, in the use case which I was asked about, like reading the soil, blah, blah, blah. So you need to think about these, what your use case is, how you're going to, yeah, what kind of what are what are these factors? Yeah, they influence in your decision to select a particular embedded system you're going to use for IoT. So another concept there is the edge computing versus the cloud computing. Edge computing, where you have the decentralized processing and storage of the data or near the source of the data generation. For example, this is what I was saying, that you can have, for example, edge devices, for example, in the cloud native environment where you are running the same microservices which are running in the cloud. Some of the organizations want them to be run in their data center, and they are the embedded devices there. Obviously, that this is where it helps. Or also, for example, if you want to process the data where it is being generated, in some of the applications, it's very crucial. For example, in the ADAS systems or other systems, you do not have so you want to have a very good reduced latency. If you want the offline preparation, real-time decision making, this is where you use edge computing. Cloud computing involves accessing and utilizing remote computing resources and services over the internet, typically by the large-scale data centers. For example, are hosted by AWS or Microsoft Azure or cloud service providers. So obviously, their benefits are elasticity and scalability, and obviously the cost effectiveness, because you are paying for a resource on a usage basis. You do not have a dedicated device just sitting there only for that use case. But obviously, again, depending on your use case, you have to find what is most beneficial, whether it's edge computing or cloud computing. Now, use of the machine learning and artificial intelligence in IoT. This is obviously quite similar to what I already explained here in embedded systems. Data analytics. So what happens is the algorithm can process and analyze the IoT data, known as the big data. So as a part of these IoT devices, the service providers are capturing a lot of data, which are to uncover the user trend patterns, things like that. So that data is fed into a data lake and then is processed later and then can be used to do all sort of things, insights, data-driven decisions, and optimize operations. So this is where the data analytics comes in. Intelligent automation. So you can also use them to automate the tasks and the processes. For example, by looking at historical data and the patterns, the machine learning algorithms can automate repetitive tasks, optimize resource allocation, things like that. For example, if I program my Nest thermostat, which is a smart thermostat, it learned my habits, and it automatically, even if I do not ask it, it can turn the thermostat to a certain temperature, on, off, blah blah blah, at particular hours, things like that. So this is where it is continuously learning and used for the automation. Self-learning system. So here the machine learning and AI algorithms enable IoT systems to adopt and learn from new data and changing conditions. So this can be used to improve their performance, accuracy, blah blah blah. Edge AI, artificial intelligence, and the edge devices make the local decisions. As I said, cloud native. Another thing which is very important is personalization and user experience, because obviously through this capturing of the data, quite a lot of information about the user is available, which can be used to personalize the user experience by providing him the things which are relevant to the user. Yeah, so this is called personalization. This is quite an important aspect, which is also used. Yeah, where which is most of these devices are using these days. Any questions on that one? Okay, so जैसे मैं शुरू में बता रहा था कि there were interoperability was a very big concern or very big issue across these IoT devices. There were no standards. There was a lot of scattered market, a lot of different use cases, a lot of different transports, a lot of different applications, and lack of standards. So what happened then? There was a consortium or collaboration, industry collaboration, started with the Connectivity Standard Alliance, formerly known as Zigbee Alliance, with the major technology companies like Apple, Google, Amazon. They came up with a standard which was initially called Connected Home over IP chips, but later renamed as Matter. Now, Matter aimed to create a unified and standard secure, standard for smart home devices, enabling seamless interoperability and easy setup across different brands and platforms. So the idea was if a smart light bulb is manufactured by one manufacturer and by the other, things like that, devices, I shall be able to communicate over them over a common standard. I shall not have to follow all different sort of APIs, messaging protocols to be able to communicate with them. So that helps with smart home integration, where using a single application or single platform, whether that is Alexa, Google Smart Home, blah, 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 all of the devices that support Matter, hubs will be able to talk to those devices over a protocol which is defined by Matter. So the Matter is designed to work over various networking technologies. जैसा कि हमने ट्रांसपोर्ट में देखा था, Wi-Fi, Ethernet, Thread, it uses existing IP protocol standards and open source technology to provide a secure, reliable communication framework for smart devices. So by adopting Matter, manufacturers can develop products that are compatible with a wide range of smart home platform ecosystem. As I was saying, like obviously, you can have, it will be compatible with the Matter running on Amazon Alexa, Google Home, by like Apple HomeKit, and quite a lot of other ecosystems. So what happened? Yeah, the Matter-enabled devices provide essential capabilities for device. As I was this, like obviously they solve the problem which we discussed earlier: device discovery, how the devices are going to discovered, how I'm going to pay to the devices, remote control, how I can use them, control them remotely, and interoperability with the voice systems. So this is how the Matter stack looks like. To be honest, if you have a look at it, you would say that very similar to the TCP/IP stack here. You have the different transports here. You have the network layer, you have the over transport layer, we often TCP, UDP, and then you have the application layer. Well, you can say it's a very simple TCP/IP stuff. Well, in a nutshell, it is. But you know, like how Matter stack solve these interoperability issues, they came up with the application layer, which is very dedicated for the application. For example, one application can be a smart light bulb, other application can be smart thermostat, another application can be security camera. Hundreds, maybe, I don't know, like maybe thousands of such applications. A lot of creativity there. Then you have the data model. Now, data model governs the messaging format, how you communicate with the device. For example, smart bulb, what are the capabilities offered by the smart bulb? Like, can you change the color? Can you change the scene? Can you turn it on, off? The messaging protocol of that is covered by this data data model. And this is where like the standardization happened. Before that, there was no standardization, and everyone was coming up with its own, which means that in order to communicate with the device, I have to know its exact specification of the APIs I have to use to communicate with that device. And obviously, there was no standard, and there the services like IFTT were coming into the picture, which were offering as a intermediary service, which know the protocol how to talk to that device, and through their like cloud service, they are providing that capability to us. But because of the standardization, now there is a single protocol to interact with all of the devices which support the Matter, which means that very good. Like everybody, yeah, like it gives a very good edge to all the ecosystems of the platform. They would not have to know all of those details. They would just follow the specification here, and they would be able to communicate with the device. For example, if I buy a smart TV from Samsung or LG or things like that, and I have a smart bulb from Lifex or um, Philips or any other, let's say some Chinese manufacturer, my TV shall be able to talk to that bulb and shall be able to turn that on and off. Like, and similarly, my phone or similarly another thing, another any platform that is running the Matter. Now the interaction model that defines like whether what kind of interaction, whether it's a read only, write only. So what they do is all of that is packaged into the binary format. It is serialized and then it is transmitted over the transport, underlying transport. So this is how like whole communication takes place. This is what I already explained, like when I was explaining the diagram. So this is more descriptive, well, description of that or explanation. If you have any question here, I can answer.
अस्सलाम वालेकुम सर सर
जी,
फरहान ये जो मैटर स्टैक है थैंक यू फॉर शेयरिंग इट्स इंडीड मतलब बड़ी एक इम्पोर्टेंट डेवलपमेंट है हम इसे मतलब स्टैंडर्डाइजेशन डोमेन में कह सकते हैं क्योंकि इन द एंड ये प्रॉब्लम तो है कि आप इतने सारे स्टैंडर्ड्स हैं इतने
एग्जैक्टली,
सारी डिवाइसेस हैं और कंपनीज अपना मैनिपुलेट कर रही हैं इस चीज को जिस तरह आप आपने
एग्जैक्टली,
अगर आपने एप्पल का इकोसिस्टम ले लिया है राइट
एग्जैक्टली,
अब आपकी मतलब इवन इफ देयर इज समथिंग बेटर फ्रॉम अनदर कंपनी आप कहते हैं नहीं यार अब चूंकि ये चीज एप्पल के सिस्टम में इंटीग्रेट हो सकती है तो मैं एप्पल का ही लूंगा या गूगल भी इसी तरह करता है कि आपका यू
एग्जैक्टली,
डोंट हैव दैट लेवरेज कि आप कहते हैं कि अब नाउ यू आर फोर्स्ड अगर आपके पास टीवी है सैमसंग का तो आप कहते हैं मैं वॉशिंग मशीन भी सैमसंग की ले लूं सो दैट मैं एक ही ऐप में या एक ही तरीके से इन सबको कंट्रोल कर सकूं सो थैंक यू फॉर शेयरिंग दिस इज इंडीड वेरी आई ओपनिंग तो इसके ये भी किस स्टेज पे है क्या हम इसके डिवाइसेस देख सकेंगे नेक्स्ट कपल ऑफ इयर्स
yes,
जो मैटर को सपोर्ट
yeah.
करेंगे
So exactly. So I think this is already quite a lot of devices are already manufactured in the field. I think it probably over a year. I think if you search for Matter certified devices, you would find a lot of devices. And to be honest, I think going forward, every manufacturer or anyone who is manufacturing the IoT devices is going to put the Matter stack into that because they are going to be forced of because of this. Nobody is going to buy any device which does not support Matter stack. It is already in the field. Like I think you just need to Google and you would find maybe I don't know like tens or hundreds of devices which are already supporting it.
हाँ ओके ओके एक्चुअली मैंने थोड़ा सा सैमसंग में काम किया था एंड आई रिमेम्बर तो यहाँ पर ना यूएस में इस तरह होता है ये बाकियों के लिए भी कि द गवर्नमेंट इम्पोजेस सम रिस्ट्रिक्शंस राइट यहाँ पर दे डोंट अलाउ बिग कंपनीज टू मैनिपुलेट हालांकि फिर भी मैनिपुलेशन है ऐसा नहीं है लेकिन गवर्नमेंट की तरफ से कोशिश होती है तो मुझे याद है कि सैमसंग को दे सेट कि आप आईओटी डोमेन में एंटर नहीं हो सकते फॉर द नेक्स्ट फ्यू इयर्स क्योंकि उन्हें पता था कि सैमसंग के ऑलरेडी इतना ज्यादा फुटप्रिंट है उनके इतने ज्यादा अगर डिवाइसेस हैं मार्केट में, तो अगर वो आईओटी में आ गए तो ये तो डोमिनेट कर जाएंगे इनको, और फिर किसी और को compete करना इनसे मुश्किल हो जाएगा। तो सर आपका क्या पर्सपेक्टिव है, कंपनीज क्यों एग्री कर गई? मतलब हम, जिस तरह मुझे थोड़ा सा एप्पल का भी पता है कि दे वांट टू कीप थिंग्स, वो चाहते हैं कि लोग उनके इकोसिस्टम से बाहर मत जाए, राइट? जिस तरह
To
आप
be
देखें ना,
honest, I
हम
think exactly.
हम्म,
To be honest, I think Apple की philosophy different है. Apple obviously they want people to be within their ecosystem because they think their devices work best. But you know, like that ecosystem is very narrow. The problem,
हम्म,
if you have a look at with the Mac OS, and you know, like you have integration, very good integration of iPad with the like watch, your iPhone with the Mac, things like that. Like when you come towards IoT, there is so much market. There are billions of devices, so many use cases. So market is very fragmented. To be honest, they realized sooner or later the only way to succeed in this IoT market is to come over this fragmentation, to let everyone a fair play. Otherwise, nobody would be. It's impossible that Apple keep offering all the devices or all the use cases that can serve. Yeah, like there can be hundreds of thousands of use cases. It's impossible. So they realize that
हम्म,
come up with like certain platform or some standard, and then like every device shall be able to work with other device. Then like it would create some kind of an ecosystem where they would get uh yeah, like they would also get benefit from it. But yeah, so I think it's because my guess is because of the too much scattered market, like this is too many use cases, they realize that it is impossible to
राइट,
build your complete ecosystem in that, and there is no way you are going to force the user to buy hundreds of those devices in that ecosystem, which means that probably user will never not be able to even buy your device. So, so I guess this is
राइट,
what happened there.
sorry. Thank you very much for sharing your perspective, sorry, thanks.
Okay, so another example of embedded system is set-top boxes. Now this is where like I spent like good 10 years so far. Yeah, like these are embedded system devices and consumer electronic devices that obviously, yeah, connect to the television, allow the user to access digital television services such as cable, satellite TV, streaming services. Now, obviously, uh, you can have several medias. For example, you can watch in Pakistan. Obviously, we only have at the moment, I believe it's well, we have the cable. I don't like what is sort of crystal there. Uh, I don't think there is a DVB, well, satellite there or DTS, direct to home. Streaming services, other interactive features. So STP is a device that, in a very simple form, let you to zap to a channel, let you to view the TV, television. But they have evolved over the time. Now they have, well, you can call them a media gateway even. They have all the smart functionalities, capabilities, combining the capabilities, traditional set of boxes with the internet connectivity. They're no longer a set-top box which like decode the signals coming over different transports, but they are the connected boxes. They are connected to the internet, not just to offer that to the user, but because they are based on different services. Quite a lot of them are over the cloud's microservices, and that's where they need the internet connectivity. They also offer capabilities of streaming services. For example, you can run the Netflix. They have the Netflix, Amazon Prime, and all sort of like those streaming applications there. And as I was saying, they provide now a centralized hub for accessing and enjoying a variety of digital entertainment options. Now they are kind of a hub, not only like television, streaming services, but even home automation. You can like some of those some of the set-top boxes let you to like have even the video cons, gesture control, you can use allows you control the like some kind of IoT devices, things like that. So to be honest, I think they are now the media hubs. They have evolved and they are very yeah. This is where to be honest, I think they have so far they have leveraged the power of machine learning and artificial intelligence to their benefit, whatever was available. Okay, the functionality, TV reception, as I said, TV channels, media playback. Obviously, they can allow the media playback from several sources, local storage, USB network drives, or even the streaming services. They allow usually on-demand services, video on demand, replay, streaming services like Netflix, Amazon Prime, Hulu, blah, blah, blah. There can be hundreds of apps. Interactive features, they let you to have a look at electronic program guide. To be honest, I think this is a very basic feature that is there since 1980s. Video on demand, the video recording, interactive applications. Now, advanced feature. So I would like to highlight some of the advanced features which have developed, like since the past. To be honest, I think digital video recording is a feature which we had since from the very beginning. This is a very old feature. That let you user to record, for later view. Time shifting of the review buffer. Multi-room is interesting one. Multi-room is where you have multiple devices in the same household, and they offer you access to the TV services and the content on multiple TVs in a home network. So if you try to play the same asset on a different device in a home, it knows where you left on the previous one. It also provides streaming to client devices. For example, you may have recorded some recording on your one set-top box, and you want to stream it to your handheld devices. For example, phones or any other devices. Then it's such powerful that it is able to transcode the content. It decode, re-encode into the format in the transport. What can be understood by that particular device and offer a viewing on that device. Like it's quite powerful from that perspective. It offers 360-degree features. For example, this is called, you can call that a casting, push to TV, pull from TV or the remote RCU, personalization services and recommendations based on individual preferences of behavior. So these devices are the connected devices, and quite a lot of data is captured from these devices to understand the user behavior and the preferences. Obviously, if the user is opted in, as it is regulated by the GDPR. Voice control. This is one of the. I would say this has happened like 4 or 5 years ago. That now we had the voice control features. You can speak, you can control the UI using your voice. You can say open Netflix on your voice remote. It would then open the Netflix. So you can do all these. You can control a lot of user interface through the voice. This is quite powerful, and this is like where the AI comes in through the natural language processing. Though most of that is happening in the cloud, except the wake word recognition on some far field devices, which happens locally. But the ASR and then NLU, the intent, artificially recognizing the intent out of the utterances happens in the cloud. Text to speech, where we have the talking user interface. For example, you enable it, then you go to the APT or any part of your user interface, then it speaks that out. It tells you this, we call that a talking user interface or talking EPD. So this is happened with text to speech. Advanced advertising, where we insert the personalized ads into the streams over the broadcast or over recordings, replay, or the VOD. We learn the user habits, and obviously if the user is opted in as per the GDPR. But then we can offer them the personalized ad. For example, if the user like McDonald's, well, he would get more McDonald's ads as compared to KFC or things like that. So we are able to insert that. We are able to do or manipulate the live broadcast through some standards, for example, the VAST or the security, to be able to do so. And similarly, in case of the IP content, like VOD replay recordings, majority of that is done on the server side, which is on the server side of insertion, where the server is inserting the ads and into the manifest itself, and we just go and play the manifest. So this is just a brief overview of the advanced features. Any questions? अगर मैं too fast जा रहा हूँ मुझे बता दो ना बीच में I can slow down. Okay, important thing, I just want to give you an overview, like where the embedded systems comes from architecture perspective. I think I also gave you a brief overview in the slides before. So I want to, like go towards a very specific application here: conventional monolithic middleware architecture versus modern middleware architecture based on microservices. So typically, microservice architecture started from the cloud, where like each of, well, depending upon the use case, people develop quite a lot of microservices to serve a very specific use case. But now it has made its way all toward, well, down towards the embedded systems, or up they into middleware is consist of all sort of different microservices, or we call them nanoservices, which let you to access those services over the different transports, for example, REST APIs through the WebSockets, through the OpenRPC or the WebSocket, all of that thing. So I just wanted to give you well, test this to let you know, like, this is how, where the things that start, or from like desktop environment or the IT environment, they make all the way down to the embedded systems, and very similar architecture is followed. I think at the moment we are living in a world where most of the architecture is harmonized, cloud versus embedded, because embedded devices are becoming powerful. There can be quite cloud native environment requirements, and the same benefits are seen, like scalability and are seen from the middleware perspective as well. So they made all the way down towards the embedded systems. So monolithic architecture में क्या होता है, entire middleware application is built as a single self-contained unit. For example, you can have the whole middleware written in form of a library, written in a C, C++, APIs, blah blah blah, and middleware applications are tightly integrated or deployed together. They're tightly coupled, very loose. There is no loose coupling, so you cannot strictly identify or decouple them. Now, scaling a monolithic middleware application involves scaling vertically, which can be very limited. So making changes to the new feature add risk to the regression, things like that. Microservice architecture में क्या होता है? You have a collection of small loosely coupled services. For example, you can have a service which is used for LED control, or a service which is server for reading the information about humidity level, or you just come up with a new microservice, or just for that only particular use case, and you make that microservice independent of each other. It have all the dependencies it needs in its own, and it can be deployed in a container, and that's where the container comes in. And then you can have that container running in a desktop environment on a data center, well, in the data center in the cloud, or you can have that running in the embedded environment on your embedded device. So this microservice architecture is more scalable, flexible. It also lets you have the different technologies. For example, one service can be using one technology. For example, you can have that in the C, C++, other can be in the Python. The third service was running on Flutter. The fourth one was, let's say, running on the Rust. You can have all mixture of services depending upon the specific requirements. Any question? Now, I want to test this operating system, which is called reference design kit. This is the operating system that has evolved, where I have a lot of contribution, and my company, they vertically have a lot of contribution. So this is an open source platform that provides a standardized framework for developing, deploying video, broadband, IoT application on set-top box devices, gateways, and other devices. So it was actually developed by maintained by the Chromecast, but now it's an independent project governed by this Chromecast, Liberty, Global, and the other companies. So main objective of RDK are to accelerate deployment of next generation video broadband services, so that it let the good collaboration between the different, and come up with, if somebody has solved one problem at one place, the rest of, it's a good collaboration, just like I was explaining with the matter. So RDK has evolved to be the good standard, to be used in video, broadband, IoT, set-top boxes, gateways. It has different flavors. RDKB is for video, RDKB is for broadband, and RDKC is for camera or IoT devices. So now this is the architecture. Now, I just want to give you an overview, brief overview there as well. That at the bottom we have a SoC. For example, you can have a Broadcom, Realtek, or another SoC. Then you have this hardware abstraction layer. So you have the abstraction layer API that it is abstracting the hardware from the hardware itself. So then you have this RDK Linux, which is the embedded Linux. Yocto is the base system there. And then we have this further things which are offered by this RDK device management. We have the services which are able to control the firmware and the features, RDK telemetry. We have certificate provisioning, power management, all of that. Then in the video profile, we have all these services. For example, the remote, voice, input, output, text to speech, IP player, far-field voice, and watermark, Wi-Fi, CEC, all of that. These are the services which are the media services, like for example, this RMS streamer, which is for media player, remote RFOC or the BLE. All of these services comes as standard with the RDK middleware. And now here, this is the interesting thing. This is what I want to show you, like how these microservice architecture or the nano service architecture came into the play here. That we have tens of these micro nano services which are looking after very specific functionality, and they have their own API definition, just an RPC defined over the WebSocket, based on the open RPC specification that let you to access those services over the WebSocket. Any application can access that. So this is how this is example of a microservice or nano service architecture in the middleware. So previously we used to have all the monolithic kind of a middleware, but here you can see how it has evolved over the period of time and how we have leveraged that microservice or the nano service architecture into the RDK. Then we have the application platform. We offer the browser, WebKit Pure Embedded, that's based on the WebKit fork. You can have the HTML5 altogether applications. This is the runtime where you can have the application running over that. This is the runtime for the applications. We can have the native applications, for example, Netflix, Amazon Prime, blah, blah, blah. They have their own abstraction layer, which we implement. Those are compiled and then run on the embedded platform. So that's a bit of a complexity as compared to what happens in case of the iOS and Android, where you can download the application just to run on your platform. You do not have to compile and build it for your platform. So now I would go into the next slide and I will explain how we have solved this problem. This is where containers are coming into the picture as well. That is through the downloadable application containers, where we package all pre-built applications into the container along with the dependencies, and they have their defined contracts through the middleware, which we implement, so that, like, the idea is that once the application is compiled and built for one particular platform, it shall be containerized, it shall have all the dependencies, and then it shall be just downloaded and run just the same way as we have Android APK, or like we have the iOS application on here. So this is what we call as Firebolt, which is like providing that abstraction layer for the APIs. So use of personalization and artificial intelligence set-top boxes of digital TV. So again, personalization user experience. So machine learning and AI techniques can enhance the user experience as TV by personalizing services and recommendations. As I said, a lot of it's a connected device. A lot of data is captured. Obviously, the user is opted in, and then this is the big data. Then that is profiled, and the user habits can be learned, and then very personalized content or services are offered to the user, search and recommendations, etc. So user experience enrichment to the voice-based navigation. This is another area where obviously leveraging the NLP, artificial intelligence, to understand what the user is trying to say. For example, when I say Netflix, we know that it's trying to open a Netflix, things like that. So there is a artificial intelligence engine running in the cloud that convert that ASR into the NLU, or an intent, then which we get back and then we act on it. So this enables interaction for more natural intuitive. And the last one is the use of like artificial intelligence. This is the other side on the packaging, where artificial intelligence encoders are used to reduce the stream bit rate by compressing the data, maintaining acceptable level of quality. They know, the artificial intelligence know the scene, things like that. For example, it know if there is little motion, so it can try to compress without dropping too much quality. So yeah, give a very good make the content much better distributable using over a low bandwidth environment, things like that. So I think we have come to the end of it. If you have any more questions, please let me know. I think we have quite a lot of time left. Probably probably we are 28 minutes over. Yeah, so if you have any questions, let me know. Yes, Abhish Kumar, go ahead.
Right, so पहले मैं कहूँगा थैंक यू वेरी मच सर फरहान महमूद फॉर दिस एनलाइटेंड डिस्कशन. आपने माशाल्लाह बड़ा अच्छा प्रिपेयर किया और बहुत आपने टाइम लगाया इसकी प्रिपरेशन में और डिलीवरी में, तो थैंक यू फॉर दिस एफर्ट. तो मेरा नाम डॉक्टर रिजवान है, मैं डॉक्टर जफर के साथ हूँ इस IOT गुरु इनिशिएटिव में. तो मैं यहाँ पे एक कंपनी है ब्रॉडकॉम में, उसमें काम करता हूँ, और मैं ये वाईफाई और ब्लूटूथ के चिपसेट्स जो डेवलप होते हैं, मैं उस टीम का हिस्सा हूँ. तो इस वजह से हमें थोड़ा सा नॉलेज है जिस बारे में आप बात कर रहे थे. तो इट्स वेरी एनलाइटेंड, बहुत सी चीज़ें सीखने को मिली हमें भी और हमारे स्टूडेंट्स को भी. सो दैट इज रियली ग्रेट. तो एक चीज़ मैं जिक्र करूंगा कि ये जो एम्बेडेड सिस्टम्स हैं, सिस्टम ऑन चिप है, सेंसर्स हैं, अब ये जितनी चीज़ें आ रही हैं ना, तो लोग पावर एफिशिएंसी के बारे में बहुत फोकस कर रहे हैं. आप जिस तरह आपने भी बात की, जो लो एनर्जी डिवाइसेस हैं, क्योंकि इन द एंड बात यह है कि ये जो हम ये सेंसर मुख्तलिफ जगह पे लगा देंगे, ये हम एज कंप्यूटिंग हम चाह रहे हैं, या हम अब ये चीज़ें मुख्तलिफ जगहों पे चली जाएंगी, बट आप उनको एनर्जी कैसे देंगे, राइट? अब आपने सेंसर्स लगा दिए ब्रिजेस पे, कि अगर ब्रिज कोलैप्स करने लगे तो हमें पहले पता चल जाए, लेकिन अब कौन जाएगा और उसकी बैटरी रिप्लेस करेगा 2 साल के बाद?
Exactly.
So that's one thing.
और बैटरी भी एक बहुत बड़ा प्रॉब्लम है, because that is an environmental hazard. Too many battery power devices, so you need to have, I think, most of the things. For example, I can tell you what is happening on the remote control side. So I think I know that there are companies who are leveraging, some radio waves, even the RF, to power the batteries, so that batteries can last longer. So there are a lot of projects which are going on to make sure that batteries can last longer or they are self-charging. So as you said, I think this is quite a lot of, well, I would say a research area, but I think I can see some interesting use cases or some results that are coming out now, which, to be honest, I think as a as an architect, I can see that we are start using those concepts to make the devices more greener. Yeah.
बिल्कुल, बल्कि अभी मेरी पिछले दिनों अपने एक फॉर्मर कलीग से बात हो रही थी, उन्होंने एक स्टार्टअप यहाँ ज्वाइन किया एंड ही वाज सेइंग दैट वी आर वर्किंग ऑन दिस, राइट, ब्लूटूथ, जिसमें आप बैटरी रिप्लेस ना करें, तो आप एनर्जी हार्वेस्ट करें। और मतलब मेरा ख्याल है ही वाज सेइंग कि सैमसंग हैज सम रिमोट कंट्रोल्स जो वो कहते हैं, क्लेम करते हैं, यू डोंट नीड टू चेंज द बैटरीज।
So I can tell you that we are working on one of that, not the Samsung, or I can not tell you the details, but we have started working on deploying this energy harvesting into the remote control.
अच्छा, माशाल्लाह, दैट्स ग्रेट। चलें चलें, आप तो कटिंग एज टेक्नोलॉजी पे काम करें, दैट्स नाइस। चलें, बहरहाल थैंक यू वेरी मच सर फॉर दिस एनलाइटेंड डिस्कशन, इतना टाइम लगाने का और इतना अच्छी प्रिपरेशन का, और हम सबको एनलाइटन करने का। तो स्टूडेंट्स, अगर आपका कोई क्वेश्चन है तो बिल्कुल पूछें, बट याद अगेन सर, थैंक यू वेरी मच।
You guys are welcome. Thanks, Rizwan. I think Abish Kumar also raising hand. So maybe Abish Kumar, do you have any question?
Yes, sir. First of all, thank you for the amazing session. Honestly, मुझे IoT का इतना आइडिया नहीं था, लेकिन आपके जो सेशन है बहुत एक काइंड ऑफ इंटरेस्ट प्रोड्यूस किया है मेरे अंदर। सर, एक चीज आपसे पूछनी थी इस IoT काइंड ऑफ बिजनेस एनवायरनमेंट के लिए, कि जैसे आपने स्केलेबिलिटी का बोला था, कि स्केलेबिलिटी का अभी तक कोई चैलेंज है IoT में मेन। और अभी रिसेंटली आई थिंक इसी साल जो है अमेजोन ने अपना अमेजोन इको, जो उसका मेन एक पावर हाउस था, वो डिसकंटिन्यू कर दिया। और गूगल ने भी पहले गूगल होम का ट्राई किया था, वो भी डिसकंटिन्यू हो गया। तो फ्यूचर में कोई जैसे बिग कंपनीज जो हैं ये अबैंडन कर रही हैं ऐसी डिवाइसेस को, तो क्या फ्यूचर IoT का थोड़ा ग्रिम है या पोटेंशियल है अभी तक? उस चीज के लिए थोड़ा पूछना था कि बिजनेस एनवायरनमेंट कैसा है अभी IoT का।
To be honest, I think IoT is challenging feat in terms of monetizing it or making money out of it. So typically we have these concepts over a decade now, and to be honest, I think since iski abhi tak uptake is very low. But to be honest, I think with more and more artificial intelligence and machine learning, I see that, to be honest, I think if I look at the deployment in the automobiles, ADAS, self-driving, this is on a full-fledged. In the consumer electronics, I think it's making, it depends on the use case. I think the customers are only going to buy if they are going to see there is some value, like not just for the fancy use case, or not just to, I am a techie, I have a house full of these appliances, but not everybody like. So to be honest, I think it depends on the use case. In some areas, IoT is going to accelerate a lot. To be honest, I think I know that some of the markets, for example, I can tell you in UK, Sky has launched a product. वो कैसे कि Google ने discontinue कर दिया, but Sky has done recently. They have offered video conferencing, because like Sky in UK, lot of homes are set-top boxes. So they are quite popular. So they have quite a lot of customers. So what they've done is they are offering a video conferencing, exercising, things like that, just to let their customer experience that they are connected they are living in a connected world, a connected environment. They can see their buddies exercising next to them, things like that. So I think, to be honest, I think wherever you can offer some value to the customer or solve the customer problem, I think this is going to gain more popularity. And but still, I think it's quite challenging. I would say so far it was very hard for people to make money out of it, and that's why most of the companies just pushed or entered into this domain just to make themselves competitive or innovative. I don't know like how much money they made out of it, but yeah. So I don't know, like, did that answer your question, Abhishek?
Yes, sir, that did. Thank you very much.
Thank you so much, sir, for the interactive session. आपने बहुत comprehensive तरीके से explain किया एक एक चीज को. I was also not familiar too much about IoT. So, sir, आपके session से काफी कुछ सीखने को मिला. Thank you so much. अगर किसी और का कोई क्वेश्चन नहीं है तो हम इसको कंक्लूड कर सकते हैं.
I think I enjoyed the session a lot as well. So thanks for all of your participation, guys.
चलें, ठीक है सर. I think we can conclude this session because we don't have any further questions. Thank you so much again. Allah Hafiz, everyone.
Thanks all.